Have you ever looked up at the night sky and wondered, what if the moon wasn't there? What if one day it just vanished? It sounds like science fiction, right? But what would actually happen to our planet if we lost our celestial companion? Let's dive into the fascinating and slightly terrifying mystery of the missing moon. For starters, our nights would become incredibly dark. The full moon is about 14,000 times brighter than Venus, the next brightest object in the night sky. Without the moon's gentle glow, stargazing would be spectacular, with the Milky Way visible even from cities. But for nocturnal animals that rely on moonlight to hunt and navigate, it would be catastrophic. Their entire world would be plunged into a darkness they're not equipped to handle, leading to a massive disruption of ecosystems. Think of sea turtles, whose hatchlings use the moonlight's reflection on the water to find their way to the ocean. Without it, they'd be lost, but the darkness would be the least of our worries. The most immediate and dramatic effect would be on our oceans. The moon's gravitational pull is the primary driver of tides. Without it, the familiar rise and fall of the sea would shrink by about 75%. The sun also has a gravitational effect, so tides wouldn't disappear completely, but they'd be tiny in comparison. This would wreak havoc on coastal ecosystems. Tidal zones, those rich areas of biodiversity that are alternately covered and exposed by the tide, would cease to exist, wiping out countless species of crabs, mussels, and barnacles that depend on this cycle. This would trigger a chain reaction up the food chain, affecting birds and fish that feed in these areas. Beyond the tides, the moon plays a crucial role as Earth's stabilizer. Imagine a spinning top. When it spins fast and upright, it's stable. But as it slows down, it starts to wobble. That wobble is what Earth would experience without the moon. Right now, our planet is tilted on its axis at a comfortable 23.5 degrees. This tilt is what gives us our seasons. The moon's gravity acts like a steadying hand, keeping this tilt from varying too much. Without the moon, our axial tilt could wobble chaotically over long periods, swinging from nearly 0 degrees, which would eliminate seasons, to extreme angles, which would cause catastrophic climate shifts. Picture this: an Earth with no tilt. The equator would be perpetually scorching hot, and the poles would be forever frozen. Now, imagine the tilt swinging wildly. A city like Paris could find itself at the North Pole one millennium and on the equator the next. The climate would become incredibly unpredictable. Ice ages could come and go with alarming speed, and extreme weather events would become the norm. Under these conditions, it would be almost impossible for complex life, including us, to survive, let alone thrive. The stable climate we've enjoyed, which allowed agriculture and civilization to flourish, is a direct gift from our lunar neighbor. The length of our day would also change. The moon's gravity creates a tidal bulge on Earth, not just in the oceans but on the land itself. As Earth rotates, this bulge creates friction, which has been slowly breaking our planet's spin for billions of years. When the moon first formed, a day on Earth was only about 6 hours long. Without the moon, this braking effect would vanish. The day would stop getting longer and might even speed up slightly due to other effects. So, while we wouldn't immediately go back to 6-hour days, we'd lose the force that has given us our familiar 24-hour cycle. So, the moon's disappearance would mean pitch black nights, decimated coastal ecosystems, and a climate spiraling into chaos. But how could the moon even disappear? It's a massive object, about a quarter the size of Earth. It can't just poof out of existence. Realistically, for it to leave our orbit, it would either need to be destroyed or knocked away by an immense force. One terrifying, albeit highly improbable, scenario is a collision. A massive rogue object, perhaps a dwarf planet from the outer solar system, could theoretically hit the moon with enough force to shatter it into a million pieces. This would create a spectacular and deadly ring of debris around the Earth, similar to Saturn's rings but much more dangerous. We'd face a constant bombardment of meteorites, ranging from dust-sized particles to city-killing asteroids. Satellites would be shredded, making GPS, communication, and weather forecasting impossible. The night sky would be filled with constant shooting stars, a beautiful but terrifying reminder of our lost companion and the danger looming above. Another, slightly less dramatic, way for the moon to disappear is if it were gradually nudged out of orbit. Imagine a series of gravitational encounters with large, passing objects over millions of years. These could alter the moon's trajectory, slowly pulling it away from Earth until it breaks free and drifts off into space as a rogue planet. This is a slow burn disaster, not a sudden catastrophe. We would have generations to watch our moon recede, its influence on our tides and climate slowly diminishing. The changes would be gradual, but the endpoint would be the same, and Earth left alone to face a wobbly, unstable future. It's a sobering thought. We often take the moon for granted, a simple, beautiful light in the sky, but it's so much more than that. It's our anchor, our stabilizer, our planet's partner in a delicate cosmic dance that has allowed life to flourish for billions of years. The mystery of the missing moon isn't just a fun thought experiment. It is a profound reminder of how interconnected our universe is and how lucky we are to have our celestial neighbor. So next time you look up at that familiar silver orb, take a moment to appreciate it. It's not just a rock in space. It's the guardian of our world. Thank you so much for joining me on this cosmic journey today. If you enjoyed unraveling this mystery, don't forget to hit that like button and subscribe to the channel for more explorations into the wonders of our universe. Let me know in the comments what other cosmic what-ifs you'd like me to explore. Until next time, keep looking up.